In this video, we're going to determine whether functions are odd, even, or neither. The formal definition of a function being even is that when you plug in negative x into the original function, you get back the original function. It looks exactly the same. And the definition of odd is that when you plug negative x into the original function, you get the opposite of the original. Even functions are symmetric across the y-axis. So looking at example A, we can see that when we look at the y-axis, I've got mirror images on either side, on the right-hand side and on the left-hand side. The idea being that if I plug in a value like 1 here, the output is going to be 1. And if I plug in -1, the output is also going to be +1. That when you go onto the right or the left-hand side of the y-axis, you get the same output value. Let's show that mathematically. Let's look at f of -x. So instead of x, I'm going to put a -x in its place and raise it to the 4th power. Well, when I raise x to the 4th power, that'll be x to the 4th, but I've also got 4 negative signs. Notice that the -x is in the parentheses. So they're going to cancel each other. These two will cancel to become positive, and these two will cancel to become positive. So it looks like overall we're getting 3x to the 4th, which is the original function back. So that means that this function is even. Let's look at another example. Looking at the graph of the square root of x, it doesn't look like it is an even function. There's no part of the graph that's on the left-hand side of the y-axis. Let's see what happens when we plug in -x. This doesn't change the function at all in the ways that we would say that it's even or odd. Even would need to look exactly the same, which it doesn't, and odd would mean that there was a negative sign out in the front of the function, which there's not. So for this example, this is neither even nor odd. For our third example, you can see that it looks like this function has been reflected twice, once across the y-axis and then also across the x-axis. We actually have a different way of stating that. We say that it's symmetric about the origin, meaning that if I put my finger right here on the origin and then I rotated this function around by 180 degrees, it would look identical. This looks like it's possibly an odd function. Let's plug in -x to see. To get an odd function, it should be that what I'm getting is a negative in front of the entire thing. So what I've done is rewritten what I had there. I moved the negative sign up in that fraction, and then I multiplied -x times 3, combine those together. If I factor out a negative sign into the front like this, you can see that what I'm getting back here, this was the original function, h of x, and there is in fact a negative sign in front. So this function is odd. One mistake that students sometimes make is assuming that if they see an even exponent on a function, that means the function is even. But you can see from the picture below that this function is not symmetric across the y-axis. Let's see what happens if we plug in -x here. I'm going to expand this out. This would be the same as negative x minus 2 times negative x minus 2, which is x squared plus, let's see, I'd get 4x plus 4. Whereas the original that I had, let's see, f of x, which was x minus 2 times x minus 2, is x squared minus 4x plus 4. These two are not equal to each other. And it's also not that one is completely the negative the other. So this is neither even nor odd.